Students, we are expected to evaluate this question, integral sin x over cos x positive sin x times dx. This is a question that featured in MIT Integration B. I would like to suggest you all to take a minute, pause the video and try it if you can resolve this question and obtain the solution. So having mentioned this, let's get on to solve this question. Now this is the integral that is given. So what I'm going to do is I'm going to just take, let I1 be equal to this integral sin x over cos x positive sin x times dx. Now I would like to take another integral that would help us to solve this given integral. So what I would do is I will also take and I2 be equal to integral cos x over sin x positive cos x times dx. So this is the second integral I'm taking. Of course the denominators are same. I just resorted in writing it as sin x positive cos x just to make some distinction. But the denominator is one and the same. The only change that we see here is with the numerator. Next, what I'm going to do is I'm going to add I1 with I2. So if I were to do this, this is going to be integral sin x dx over, I'm just going to write it as sin x positive cos x followed by integral cos x dx divided by sin x positive cos x. Now this can be rewritten as integral. Now the denominator is same, so I'm just writing it as sin x positive cos x. The numerator, I take sin x here, I add it up with cos x and I get a dx. So clearly we see that sin x cos x, they get neutralized. So we are left with integral dx. So if I were to integrate this, I get x positive. See, that is for I1 positive I2. This is what we have got for I1 positive I2. Now let me consider this. Consider negative I1 positive I2. So what is that going to be? So that is equal to, I will have a negative sign here, negative sin x divided by sin x positive cos x times dx. Positive for I2 is going to be cos x dx divided by sin x positive cos x. So if I were to rewrite this, I can rewrite this as cos x negative sin x times dx divided by sin x positive cos x, right? So now let me make the following substitution. Let sin x positive cos x be equal to sum t. If I were to differentiate this, I get cos x. If I were to differentiate this, I get negative sin x times dx is equal to dt. So if I were to substitute the quantity, this is going to be cos x negative sin x is, of course, with the dx being present there, that's going to be dt. Sin x positive cos x is t. So I get ln t, which is nothing but ln, you need to place the modulus sign. So my t is nothing but sin x positive cos x, positive arbitrary constancy. So probably we can have a c1 here and a c2 here. This we have got because I've taken negative I1 with I2. Now we have two equations actually. We got negative I1 added with I2 to be the quantity that you see here, and I1 added with I2, the quantity that you see there. Now we are expected to obtain this, which is nothing but I1. So for that, what I wish to do is I would have to do two things. So that means I need to subtract. Say if I were to take this as 2 and take this as 3, I would have to subtract the following 2 negative 3, equation 2 negative 3. So if I were to do that, the first one is going to be I1 positive I2, okay, followed by negative of negative I1 positive I2. This is for the left hand side, which is equal to the first quantity x positive c1 parenthesis negative the second quantity, that's going to be ln of sin x positive cos x modulus, of course it's going to be negative c2. Now what happens here, I1 can be added with I1 here, so it's going to be 2 times I1, I2 minus I2, that gets annihilated. So we now have x negative ln of modulus of sin x positive cos x. Now you got a c1 minus c2. So c1 minus c2, of course I'm going to write it like this, positive of c1 minus c2. I need only I, so in fact I1, which is nothing but x negative ln of sin x positive cos x divided by 2 positive c1 minus c2 divided by 2. Now I can rewrite this as a capital C. So let me conclude the question. So what is I1? I1 is this quantity. So therefore integral of sin x divided by, maybe let me write that down as cos x positive sin x. It doesn't matter, but just to have the similarity, is equal to this quantity, which is nothing but x negative ln of modulus of sin x positive cos x divided by 2 positive arbitrary constant c, which is nothing but c1 minus c2. So this is the solution for this question. And conversely or alternatively, if they were to ask us given this integral, then we would be also able to extract it. So that's the end of this solution, students. I hope you enjoyed this question. Keep trying, keep practicing. Have a nice day.